Very good question, and it gets a lot of thing, right? So let's see. So the question is basically LRU cache, and we have to maintain a cache where we have to do a get and a put operation in a O of one time, okay, and space, not space, O of one time and O of n space. Now, so the question is basic. Whenever we update or get an element, the frequency increases, and whichever element is in the last, if the capacity increases to that element, that has to be removed. Okay. So to understand this question, we'll not simply go and write some notes. We'll code it and we'll go one by one. So now, first thing first is that we need a capacity first, right? So let's make this dot cache equal to new map. Okay, so we need this map to save our elements. Now let's check few things. Okay, let's check few things. So what we can do here is logic is basically suppose we have 1, okay, then we added 2, then we added 3, okay, and suppose the capacity is of 3, that we can only add 3 elements. So when we add 4, we'll add 4 and we will remove this 1. Okay, so what we will do here is we'll maintain 2 pointers. Okay, 2 pointers, that is a left and a right. Okay, initially the left will point to right and right will point to left, like that. Now whenever we add element, we'll say okay, add in between. Okay, so not in between, that whenever we're adding, that is basically we have to add in the rightmost because that is the most recently used. Okay, so we'll say okay L, and we have to add before right. So suppose we need to add 1, so like this we added 1. Now we need to add 2, so 1 will remain here and this 2 will come here. Okay, so whenever we add, we need to add before right. Okay, and it makes very intuitive that whenever we remove, so remove after left. Okay, basic things. And so now what we need to do is, let's go to the code. So basically for the linked list, now we need a node. What happened? I think I pressed run. Okay, no issues. Let's try to code it up. So we'll say class node. Okay, we have a node class here and we will have a constructor, and this constructor will take key and value. Okay, this is just the node, and we can say this dot key equal to key, this dot val equal to val. Okay, now for every node there is a left and a right pointers, so we'll say this dot left initially null, and this dot right, that is also initially null. Okay, not left and right, basically this is next and previous. So this is the node structure that we need, right, for a doubly linked list. Now in the constructor we got the cache. Okay, once we got the cache, what more we need? We need to save the capacity also. So this dot cap equal to capacity. Okay, once we got the capacity, what else we need? We need the left and the right guy, right? So we'll say this dot left equal to new node, else mark it 0 key 0 value. Similarly we'll say this dot right is also a new node, let's mark it 0 comma 0. Okay, now the initial structure is left is pointing to right and right is pointing to left, right? That will be our initial structure, and we need to add in between. So we'll say okay, this dot left dot next, what it is pointing to? It is pointing to nothing but this dot right, and this dot right dot previous has to point to this dot left. Okay, so our constructor is ready. Now the thing is, we don't want to clutter our code, so we'll write a basic helper functions that will insert and remove nodes. Okay, so let's say when we want to remove a node, so this teaches how to remove a node from a doubly linked list. So now when we need to remove a node, okay, so suppose there is 1, there is 2, and there is 3. So whenever we need to remove the node, okay, here we don't need to check whether it exists or not, that we'll check in the main get or post method, but for here we have to just remove one, we have to just remove the 2. So we'll say, okay, whatever the previous is, okay, that we have to connect here, right? This should be the new connection. Okay, so we need the previous and the next, right, of 2, and connect these two. So we'll say, okay, const previous equal to whatever node we are given dot previous, and const next equal to whatever node we are given dot next, and then we have to do previous dot next is next, and next dot previous equal to previous. So now we remove the node, okay, this connection is gone for this node, so it is gone. Now to insert a node, how to insert a node, okay, okay, whenever we need to insert a node, we know that it has to come before write, correct? So here the previous element will be this dot write dot previous, okay, I guess we have named it previous only, yeah, okay, this dot write dot previous. So we got the previous node. Now we have to add the element between this previous and the write, okay, so we'll say, okay, previous dot next equal to this node, and node dot previous equal to previous, okay. So this connection is done. Now also node dot next equal to this dot write, and this dot write dot previous equal to node. So we made all the connections, right? So now we know how to insert and remove a node, okay. Now when we need to get the key, right, first we have to check if this, whether this is there on cache or not, right? So what we are doing here in the cache we are simply, so the cache will be a key to node, okay, so we can check the key and we can get the node, right? So we'll say if this dot cache dot has key, if it doesn't have the key, then simply we have to return a -1, but if it has the key, okay, then let's do one thing, let's take the node, const node equal to this dot cache dot get this key, okay. Now we got the node. Now what we need to do is, right, wherever the position is, so this will go to the now most recent part, that is in the right, previous of the right. So we can simply remove it from, it can be the LRU, okay, it can be the LRU, suppose we need to remove one, okay, it can be in the LRU, that is this is the LRU, or it can be anywhere in between. So simply we can remove it, we don't want to check whether it is, and we have to add it here. So we can say, okay, this dot remove what node, remove this node, okay, and then again this dot insert this node, okay, and simply return node dot val, okay. So get is also done, and now the last guy put. So when we need to put a value inside, okay, so what we have to do here is there might be a condition that this node is already there, okay. So we'll check, okay, this dot cache dot, to put this all inside a if this dot cache dot has this key, if cache has this key, okay, then we can simply say remove this guy, correct, we have to simply remove this guy. So we'll do this dot remove this dot cache dot get key. So we removed this guy, correct? And now what we have to do here is we have to add the element, right? We have to add this element. If the key is oh, just one thing. If the cache has key, remove it. Okay. Now the cache, this particular list is not there in the linked list. Okay. If the cache doesn't have key, okay, then what we can do here is we can create a new node, const new node equal to new node with this key and val. Okay. And we can say this dot insert this new node. Okay. And after inserting this new node, we can say this dot cache dot set this key, sorry, and new node. Okay. This is fine. Now what happens if this dot cache dot size become greater than capacity, correct? Then we simply have to give the LRU. And where is the LRU? Const LRU. LRU is at this dot left, sorry, left dot next, and we can say this dot remove LRU, and also this dot cache dot delete LRU key. Okay. So in this way, let's run it once. Okay, I think we have right value here. Accept it and submit.